right, good morning, afternoon, whatever it happens to be on this slightly chilly but better than it has been day. So today we're going to look at 5.5, and a couple of other ones probably, but one of the things we want to do is we want to develop some scripting for example, we can convert binary to decimal or decimal to other functions. So in this case, we're going to do a conversion from decimal to base 16. So base 16 seems a little weird. So first we're going to take a look at it and kind of show you where we see it and where we can find it in other places. So the computers love base 16 for a simple reason of it really is a power of 2. So we have a set of values. So when we count in decimal, we stop here. But I need to get to 16 different values. So this is kind of my conversion chart. I forgot poor D. I'm trying to type here. So what this is equivalent then to, so here's my hex decimal, we call it, and here is my decimal. So these are the same. And in fact, I'm just going to cheat and copy and paste. But here, that really represents the value of 11, 12, 13, 14, 15. So we have to be a little careful. A, B, C, D, E, F. All right. So when we get to these values, how do we start converting from hexadecimal back to decimal numbers, and how do we deal with these numbers? So one of the places we see them, good, it's nice and big. All right, so if I come into my computer and I do a ipconfig/all, I'm going to see some of these in our addresses. So in this particular case, I see something here called a physical address. Well, what I'm trying to convey is a lot of information, and the simplest way I can do that is put it into base 16, because I can display a lot more information in 2 characters that would take 3 in decimal. So down here I have decimal. I'm actually doing the same amount of data in 2 characters here as I do in 3 down here. So as my IP addresses move to version 6 here, and they get longer and longer and longer and longer and longer, it's easier to display them in hexadecimal. We do our physical addresses in those. If you look on your phone, you're going to see it. In this case, our DNS servers here is a set of hexadecimal. So we use it all the time. We just don't realize that we use that as quite as often as we do. So other places you're going to run into this. So it's kind of a handy thing to be able to force those to flip around. So here we've got kind of a beginning of a program. So power of 2, we can convert from binary to hexadecimal pretty easily. So now we have to figure out how we can convert back and forth. And I can show you manually how to do it, but we want the computer to do it for us. So this might be an example of something we're going to look at. All right, so we're going to create a function called rep to decimal. So here we're calling that and passing in a set of values. So expects 2 arguments, a string and an integer. The second argument should be the base. So not only are we able to convert to hexadecimal, in this case, we can convert binary, we can convert to octal, we can convert to binary and base 16. So what we're going to do then is create a lookup table, so it says. So we're going to use our dictionary, our friend that dictionary, so if we have a value, we can automatically pull it across. So value stored with each key. And the main loop should convert each digit to uppercase, look up its value in the table, and use the value in the computation. So they give us this, they give us some output. So we can actually start building that then from this pretty quickly. So I'm going to come down a couple lines, and I'm going to make this a little bigger so it's easier to see. And the first thing I'm going to do when I look at this is I'm going to create that table of digits. All right. And so, digits, I can't spell today. Base 16. That way we have all of them in this list all in one place together. So we're going to call it rep table, since we're calling it rep to decimal is the function. So rep table. And then I'm going to set an equal sign. And what I'm going to do is I'm going to use the brackets. So above the square braces, I'm going to put those in. And that's going to say, hey, we're going to create a dictionary. So a dictionary has a word or an item and an explanation. Well, we're going to use that for a little other purposes, but here we're going to say, so 0 is equal to 0. And so that's a digit inside of it. And so then we could say 1. And so when we say 1, we get returned the value of 1. So 2. So this is going to take a little bit of time to set up. So I just want to kind of show you how we get through these. So we're going to go all the way through the alphabet here. So I'm going to go through 2. And then I need to set it all the way up until we get to F at the end. So at some point I'm going to have and I'll use uppercase A. A is equal to 10. B is going to be represented by 11. C is 12. D 13, E 14, and F 15. So we get all those in there. And so I'm going to cheat just a little bit and copy that in just because I don't want to retype it all and spend half an hour doing that. So you end up with a table that looks something like this. And so anytime I reference any of these items, so if I reference 3, I get the numeric value for 3. If I reference D, I get the numeric value for 13. So that allows me to look at these and try to perform some mathematical operations on it. So the next thing we need to do is we need to create our function. And they gave us a name to even use, so we can just simply define, we can make the lowercase define, and we're going to call it rep to decimal. And because it's referenced down there, it's already stored in its little storehouse there. And we're going to actually pass in 2 things into there. So we're going to pass in rep and the base. So we're going to pass in both of these items. So a representative value and what base it is. So we pass two things into this function. So it's going to take whatever we pass there in as a string, and it's going to flip it back out as a decimal. So this is what we're going to output. So at the very bottom of this, we're going to return decimal. So I'm going to start out by using that value decimal equals 0. So I have a couple of different ways we can convert this. We need to figure out what base it's in. We need to figure out how we're going to modify that value to fit that. So if I get, let's use an example. Let's say I get B, which is actually 11 in decimal, but I have several digits in there. I need to figure out how I can put those back together again. Alright, so let's just create a value, and I'm just going to call it, well, let's call it exponent. See if that's a keyword. Oh, isn't. Great. And I'm going to say that's equal to the length of that value that we got sent in. So we want to know how many digits long it is, and we're going to take 1 away from it. Minus 1. And that's, again, that correction back to binary, because remember, we start counting at 1, the computer starts counting at 0. And then we need to create a loop. And we're going to just pull out, so we could use for x in rep. So in other words, we're going through rep in stages, pulling out content. Decimal is equal to decimal plus rep table. Now, even though we use the brackets to create the dictionary, we use the square brackets to reference it. So whatever position we're in here. And then we're going to simply take it times the base, and we're going to raise it to the power of our exponent. Then, to make sure that this loop actually does decrement every time, we're going to take that exponent equals exponent minus 1. So that way our exponent will go down each time this thing fires off. And then, of course, we have at the bottom, we have our return decimal. So we can move that up a couple lines to make it all in there. So decimal goes through and gets converted. We return our decimal, and then we have a set of tests. So remember, this is just something I typically have on my start menu. So what this does is fires off this main function. So it comes up here and it runs this main, and in this case it should enter in several different numbers to try what happens in different formatting. So in this case it should say what is 10 in base 10, what is 10 in base 8, what is 10 in base 2, and what is 10 in base 16. So the same number, but in different bases or math models. So let's see how badly I screwed that up. Oh, not too bad. So 10 in decimal is 10. 10 in octal is 8. 10 in binary is 2. And then it's 16 in base 10 or base 16. So these are some of the things that we can utilize these little programs for. Now, you're not asking it for data, but you certainly could change this to ask it for data if you wanted to. So we're just using a lookup table. And some of you may be going, well, wait a minute, I don't understand why base 16, why is 10 at 16? Well, it's the same as what we do in our decimal operation. So we're in the 16s column and we have one of them, and it gives us that value of 16. You can check this, you could change that. So let's see what happens if I change them all to 11s. And run it. So you'd see the differences here. And certainly we could change this a little bit. So I would probably do something test value equals, and then change out these for test value. And that's probably going to grade it incorrectly when I do that. But what this does is let me put in any value and test it. So we could simply change it to that. And unless I probably missed a comma somewhere in there or something silly. But what you can do is create this so that it would put in a different value and you can test it very easily. You could then do a couple of other things. You could then ask for the user to input a data. So you could say, what is this value in 3 different formats? So it's just kind of an interesting start to our operation here. Screw that. There it is. So, this is probably one of the easier ones, except for the math piece. But we've already seen that, and they show you in your book how that actually functions. But oftentimes it's kind of handy. We may want some kind of little converter tool like this. So we can process our data and see what it would be in different data sets. You're not limited to using these. You could do a base 32. What you are limited to at this formula is essentially powers of 2. So there's other formulas we could convert if you had something really weird, like a base 17 or something. Alright, so if we go in and check the grading on it, make sure that we get the right outputs, and we do. Yay! Alright. So I'm going to close this one. I'm just going to set these in smaller videos. Maybe I will have more luck getting people to see them.